Assalamu alaikum, dear students of standard 9. How are you? Welcome back to my physics class. So today, what I will explain, can you tell me? Yes, by seeing the wallpaper, I think it is clear to you that today I will explain sound. That is your chapter 7 from your physics book. Let's look what I will explain today. I will explain simple harmonic motion and I will explain something about waves. So simple harmonic motion. What is simple harmonic motion? At first I have to make it clear. Oscillatory motion under a retarding force proportional to the amount of displacement from an equilibrium position. This type of motion is called simple harmonic motion. But before understanding simple harmonic motion, we need to make clear some related term, that is oscillatory motion, then restoring force, and simple harmonic motion. So oscillatory motion, repeated back and forth movement over the same path about an equilibrium position, such as a mass on a spring or pendulum. Look here, a mass is attached to the one end of the spring, and we are seeing there is a back and forth movement of the spring. That means one half of its time period the spring moves in another one direction, and in the rest of it moves in the opposite direction. So in this way it moves to and fro or back and forth motion, and this type of motion is known as oscillatory motion, and it is also simple harmonic motion. So if you can see, when the mass is attached to the spring, the length of the spring is increased, it moves further, but again it tries to move go to its equilibrium position. That means a retarding force is acted, for which it tries to move to its equilibrium position. So now I will make you clear what is the restoring force. A force acting opposite to the displacement. Look, to bring the system back to equilibrium, which is at rest. The force magnitude depends only on displacement, such as in Hooke's law. You know from chapter 4, maybe chapter 3, that about Hooke's law, that is F equal to minus kx. Now simple harmonic motion, oscillatory motion where the net force on the system is a restoring force. So these two terms are very much related to simple harmonic motion. That means simple harmonic motion is a kind of oscillatory motion where the net force on the system is a restoring force. Look here, I have written one formula, T equal to twice pi root m by k. This formula is for the time period of a spring when the spring moves in back and forth motion. So look, in your book there is no scope of deducting it, but there is no harm in knowing it. Look dear students, T equal to twice pi root m by k. This equation derivation you will learn in HSC level. So in your book there is no derivation given related to this, but you need to know the formula. So here, if the spring constant of a spring is k, look here, k is the spring constant and m is the attached mass. Look here, a spring and a mass is attached to the spring. So the mass of the attached mass of the is m and the spring constant is k. Then the time period can be found out by this formula, T equal to twice pi root m by k. So this formula where we can find out the time period, it depends on the mass of the object which is attached to the spring, and here k is constant, spring constant, twice pi, this is also constant. So here the time period depends on the mass that is attached to the spring. And there is another formula T equal to twice by root L by G. It is for simple pendulum. Look, in simple pendulum also we are seeing oscillatory motion. Okay, look here. The bob moves back and forth or to and fro motion. Look here. The bob at first taken to this position, then when we you can see that then the bob will move from here to here and again come to here. In this way it completes one vibration, and we can find out the time period of completing one vibration by this formula T equal to twice by root L by G. So here T equal to twice by root L by G. This L is the length of the string. Look here, the length of the string is L, and G is acceleration due to gravity, and time period T equal to twice by root L by G. Here we are not using the spin constant because it is a simple pendulum, and in case of spin you can see the spin constant is used, and here the mass of the object which is attached to the spring, that is also very much important, that is also included in that equation. But look here, the mass has no use in this equation. T equal to twice by root L by G, where L is the length of the string and G is the acceleration due to gravity. So look here, no mistake has occurred whether you hang a light mass or a heavy mass. The time period will be same. It doesn't depend on the mass. Now, periodic motion. Dear students, you can ask me this type of motion you have learned in chapter 2. So why I am again explaining this? Because these things are very much important to understand wave. That's why these are related to wave. If the motion of a moving particle is such that it passes through a definite point along the path of its motion in the same direction in a definite interval of time, this type of motion is called periodic motion. The hands of the watch and the electric fans are the example of circular periodic motion. The contraction and expansion of spring is the linear periodic motion. The time required for a complete oscillation of an object executing periodic motion is called its time period. So look here, the hands of the clock moves from the same direction for the same time period, and this type of motion is known as periodic motion, and it can be linear, it can be circular. Oscillatory or harmonic motion. So if a body executing periodic motion moves in a definite direction for one half of its time period and exactly for the other half in the opposite direction, then this motion is called oscillatory or harmonic motion. Look here, the cradle, the swing. At first the swing is taken in this side, then when it is moving, look here, it's one half time period it moves in one direction, and in the next half time period it moves in the opposite direction. So this type of motion is oscillatory or harmonic motion. If any spring is hung from a strong support and an object is attached at the lower end and released after stretching, the spring will vibrate up and down. That I have shown you few seconds ago. This type of motion is known as oscillatory or harmonic or vibratory motion. Motion of a simple pendulum and motion of a vibrating tuning fork is a harmonic motion. I think simple harmonic motion or oscillatory motion is clear to you. Now I will explain wave. The periodic motion of a particles which transfers energy from one place to another through a material medium but does not displace the particles permanently is called wave. The wave produced in solid, liquid or gaseous medium is called mechanical wave. Water wave, sound wave, etc. are mechanical waves. To transfer the mechanical wave, elastic medium is needed. There is another type of wave that does not need any medium to propagate, which are called electromagnetic wave. That is light. We get light without any medium. So light is an electromagnetic wave. So look here, when a stone is thrown on the calm water of the pond, then look here, wave is created, and this wave is propagating in the water medium, and when it will strike the end of the edge of the pond, then the wave will be stopped. The movement of the water particle will be stopped. So here, this wave propagates and it transfers energy, but it doesn't displace any particle permanently. That means the particles of the water medium will vibrate in their equilibrium position, but they will not permanently displaced from their equilibrium position. So the wave created by throwing a stone on the pond water is shown here. I think it makes you more clear about wave. Now, the characteristics of the waves. The wave is produced due to the harmonic motion of the particles, but the particles are not displaced permanently. Why it is harmonic motion? Because here also the particles vibrate or vibrate back and forth. That's why it is harmonic. A medium is necessary for the propagation of mechanical wave. The wave transfers energy from one place to another. The velocity of wave depends on the nature of medium. The reflection, diffraction and superposition occur in case of wave. So these characteristics you must memorize, because it will come as your two marks question, that means B number question. Now, classification of wave. There are two kinds of wave, transverse wave and longitudinal wave. So let's look the picture of transverse wave and longitudinal wave. Longitudinal wave, look here. Longitudinal wave propagates by making compression and rarefaction. Look here, in case of spring, when the spring is compressed and the rarefaction of the spring is shown. So in this way, by making one compression and rarefaction, compression, rarefaction, compression, in this way the wave moves or propagates, and the highest distance it will travel is known as the amplitude, and this is transverse wave. So look here, in the positive half cycle and in the negative half cycle. Okay, look, positive direction it will move, it is the maximum height, and in the negative direction it is the maximum height, and this maximum point is known as crest, and in the negative direction it is known as trough, and the distance between two crest or two trough is wavelength. Okay, and the maximum distance it is displaced, the wave transmitting particle displaced, is known as amplitude. So this height is amplitude. And when the wave moves from here to here, it completes one vibration. So we are seeing here three vibration, because here to here one, here to here another one, and here to here another one. So here three vibrations are shown. Now, difference between longitudinal and transverse wave. Dear students, you must memorize this one also. It also come as your remarks question. So transverse waves consist of crest and troughs, and longitudinal waves consist of compression and rarefaction. There are no pressure variations. There is a pressure variation throughout the medium. They can be propagated through solid and surface of liquids, but not gases. They can be propagated through solid, liquid as well as through gases. It, in transverse waves, the particles of the medium vibrate at right angles to the direction of wave propagation. And in longitudinal wave, the particles of the medium vibrate parallel to the direction of propagation of wave. There is no change in the density of the medium. There is a change in the density of the medium. Light wave is an example of transverse wave, and sound wave is an example of longitudinal wave. So from here, you can memorize only any of the three differences if it comes as your B number question. Now, wave related some quantities I will explain. Complete vibration. If a wave transmitting particle moves from a certain point and again comes back to the same point, then the motion is called complete vibration. So look here, from here to here, it completes one vibration. Time period. The time interval in which the wave is repeated, that is the time required for one complete vibration of a wave transmitting particle, is known as its time period. That means look here, from this point to this point we are seeing one vibration. So for completing this one vibration, the time which is required is known as time period. So time period is the time for completing one vibration. We have to memorize this definition because very much important. And time period is expressed by the letter T, capital T, and its unit is second. Now frequency. The number of complete vibration in 1 second of a wave transmitting particle is known as its frequency. That means how many number of vibrations will be completed in 1 second, that is known as frequency. That number of vibration done in 1 second is known as frequency. So wave is produced from a vibrating object. So the frequency of a vibrating object is equal to the frequency of the wave. The unit of frequency is hertz. If a vibrating particle executes one complete vibration in 1 second, then its frequency will be 1 hertz. So you have to memorize also this one. What does it mean, 1 hertz or 10 hertz? So if it comes in the exam, what do you mean by 10 hertz? So that means if 10 vibrations are done in 1 second, then the frequency is called 10 hertz. So it is expressed by F. The relation between frequency and time period is F equal to 1 by T. You must memorize this one, this formula. This is a formula also. F equal to 1 by T. If you know time period, then you can find out frequency. And if you know frequency, then you can find out time period very easily. That means frequency and time period are inversely proportional. Wave velocity. The distance that a wave travels in 1 second in a particular direction is called wave velocity. Now amplitude. To produce a wave, the particles need to vibrate through their equilibrium position. The particles are vibrating in this way. Okay, so from their equilibrium position. The maximum displacement of a wave transmitting particles from the position of equilibrium is called amplitude. So look here, this one is the amplitude. Here it is the maximum height, and in the positive direction, and in the negative direction this one is the maximum height. So this is also amplitude. Phase. Now I will explain phase. The overall condition of a motion of a wave transmitting particle at any moment is known as phase. Its Bengali meaning is dasha. The overall condition means the displacement, velocity and acceleration, etc. of the particle at a certain time. The wave crest or the wave trough always remains in the same phase. That means two crests are in the same phase and two troughs are in the same phase. Look here, P and P prime are two crests, they are at the same phase. That means they are at the same condition. And here two trough, that is R and R prime, they are at the same phase. And you know, the distance between two crests or distance between two trough is known as wavelength. Now I will explain wavelength. The distance between two successive particles of same phase is called wavelength. So look here, on this wave, if I consider two particles P and P prime, so the distance between these two successive particles is known as wavelength. Wavelength is defined as the distance through which a wave travels in a time during which a wave transmitting particles complete one oscillation. That means wave is not only the distance between two trough or two crests, it is also the distance traveled by the wave for completing one vibration. That means from this point to this point, the wave completes one vibration, and it is also, this distance is also the wavelength. And it is expressed by the symbol lambda. The symbol of wavelength is lambda. This symbol lambda, and its unit is meter. Look here, P prime, R prime, S prime are in the same phase, and this distance is also wavelength. So dear students, today I am to finish my lecture. I think the things are clear to you. If not clear, you will consult with me, and in the next class I will explain some more interesting things. So till then, stay safe. There is a nice moral for you. The desire of this world are like sea water. The more you drink of them, the more you thirst. Good night, everybody.